We were looking at alcohol specifically. So we said every organic compound has two names, IUPAC name and the common name. Now, under the IUPAC system, we said alcohols are named by replacing the last letter E of the corresponding alkane by "ol." This makes the name alkanol. When I look at the common system, alcohols are named as alkyl alcohol. So we spoke about one example. If I have CH3OH, if that is the compound that I have, now when I look at CH3, it is derived from methane. So if I have to name this particular alcohol, it will be methane plus all. I will remove that E and the name will become methanol. Likewise, when I look at the common system, in the common system too, since CH3 is a methyl group, we call this alcohol as a methyl alcohol. So this is how we name compounds according to the IUPAC as well as the common system. Then I gave you a homework. So homework was this. So we looked at a set of compounds here. I asked you to write down these compounds and then find out what the common names and the IUPAC names are. I hope you have all given a try to find the names of both the common as well as the IUPAC. If you have, and if you have written down the names, let's try to check whatever you have written and what I have with me are true. So this is what I have now for you. Now, when I look at the first one, the first compound here, CH3OH. Now, the common name is methyl alcohol because the R group that is here is a CH3, which is a methyl group. So, when we follow the convention, it should be alkyl alcohol. So, therefore, here it is methyl alcohol. And when I talk about the IUPAC name, now in the IUPAC name, we look at the root word. Now, the root word talks about the parent chain. Parent chain is nothing but the longest continuous chain of carbon atoms. Now, when I look at this chain here, there's only one carbon in the parent chain. Therefore, the root word is meth. So, meth, the nature of bonds are single. So, therefore, in, and then I have the functional group here, which is OH, and it is an all. And when I combine all these together, I replace that E with OL, giving me methanol. So the first compound is named as methanol. Second one should be pretty straightforward. This is propyl alcohol, but to be more specific, whether it is a straight chain or a branch chain, we use the term N or iso. Since this is a straight chain compound, we use the term N indicating normal. So this is normal propyl alcohol according to the common system. And when I look at the IUPAC system, as always, we go ahead with the root word 1, 2, 3. This is my parent chain prop, and the functional group should be given the lowest number. So I start numbering from the right 1, 2, 3. So 1 propanol or propan 1 all. So this is how we name it according to the IUPAC system. And coming to the third one, in the third case, I have 1, 2, 3. Once again, I have a propyl group. But the difference between this and the previous one is that this is a branched chain. Now, how do I indicate branched in terms of the common system? We use the term iso. Now, iso is used to indicate a branch, and this is a propyl group. So, therefore, the common name will be isopropyl alcohol. Then, talking about the IUPAC name, in the IUPAC name, root word, so 1, 2, 3. This is my parent chain, 3, so therefore, prop. At the second position, I have the functional group. So, therefore, prop and 2 all. And coming to the fourth one, this is a straight chain once again. So therefore, N-butyl alcohol. Clear? N-butyl alcohol. Then the IUPAC name will be butan 1 all or 1 butanol. Talking about the next one here, secondary butyl alcohol. So this is secondary. Why are we using the term secondary prefix here? It's because OH group is attached to a carbon which is in turn attached to two more carbon atoms. Remember when we spoke about the types or classification, we said we have a primary alcohol, a secondary alcohol, and a tertiary alcohol. Now here this is a secondary alcohol because OH is attached to the second one. So it's a secondary butyl alcohol, or you can also call it as isobutyl alcohol. Both are one and the same. And talking about the IUPAC name, so this is butan 2 all. Yeah, so this is what I have. Going back to the fourth one, in fact, there's a mistake with this. So this and this are exactly the same. So while there's been a typo error here, so the name for this will be exactly similar to this and this, which means anyways, let me not waste the common name and the IUPAC name, whatever is mentioned. I want you to take this as homework. I want you to write the structure of 2-methyl propan 1-all. I want you to write the structure of this 2-methyl propan 1-all. So make a note of this 2-methyl propan 1-all, and I want you to write the structure of for this particular name. All right. So then we have the next one. Here, this is a tertiary alcohol because OH is attached to a carbon, which is in turn attached to three more carbons. Therefore, this is a tertiary alcohol. And what is the group here? Now, this group here, which is attached to OH, is a butyl group. So, therefore, the common name of this compound will be tertiary butyl alcohol. Clear? And coming back to the IUPAC name, once again we follow the rules. Root word 1, 2, 3, or 1, 2, 3, any which way I can choose. If I choose this as my parent chain, then I'll have 2-methyl. So the second position I have a methyl group, and the second position I have the functional group. So 2-methyl propan 2-all, which is what is mentioned here. So 2-methyl propan 2-all. And coming to the last one that we wanted to discuss, the common name of this is glycerol. Yeah, this is glycerol, and glycerol's IUPAC name is 1, 2, 3. So therefore it is prop 1, 2, 3. At all the three positions I have an OH group, so therefore it will become a triol. So propan 1, 2, 3 triol. I'll just keep this slide open for a few moments. If anybody would like to make a note of the same, you can make a note of it. So just understand, whatever compound is given to me, I just follow the normal rule that we discussed, the normal format. If I have to name it according to the IUPAC system, I'll be naming it as alkanol. If I have to name it according to the common system, I'll be calling it as alkyl alcohol. So you follow that, you just look at the structure there. Based on the structure, you identify who's the R group, you identify who's the parent chain. Accordingly, it's quite easy for you to write down the common name as well as the IUPAC name. All right, so now coming to phenols. Now phenols too, so I have a few phenols written here for you. This has both the common name as well as the IUPAC name. Now, phenol is a common name. You can use it as a common name itself. If I have to look at the IUPAC name of phenol is nothing but benzenol. IUPAC name of phenol is benzenol. That's how you try to name it according to the IUPAC system. Then I have this. Now, what is the difference between this and this? I have a chlorine which is attached at the para position. Now, last year in the last chapter, we looked at the different positions that can be there on a substituted benzene. So if I have a substituent attached to a benzene, I can have different positions. These two positions, the positions that are closest to that substituent, to that group, they are called as the ortho positions. The group or the positions which are intermediate to the group, we call these positions as the meta positions, and the position that is farthest away from this group, or this position is farthest away from this group, we call that as the para position. So when we are talking about the common name, we'll be using ortho, meta, and para when we are talking about substituted phenols. When we're looking at the IUPAC name, we follow the normal process. We just give the numbers. Based on the number, the position is indicated in the name of the compound. All right, so when I look at naming this compound, now Cl is at a para position to an OH. So therefore, this compound is called as para chlorophenol. So this is the common name. If I have to look at the IUPAC name, it is 4-chlorobenzenol. Now, why is it 4? This carbon which is having the OH is given the number 1, 2, 3, and 4. So 4-chlorobenzenol. Then coming to this one. Now this group is a nitro group. NO2 is a nitro group. And where is it positioned? It is positioned at the meta position with respect to the functional group here. So therefore, this compound in the common system will be named as meta nitrophenol. So meta nitrophenol will be the common name. If I have to name it according to the IUPAC system, 1, 2, 3. The nitro group is present in the third position. So therefore, 3-nitrobenzenol. 3-nitrobenzenol will be your IUPAC name. Going to the last compound that we have here on the slide. In this case, I have two substituents, and both the substituents are nitro. And where are these nitro groups attached? They are attached at the meta position. Clear? So here you have an option of writing M, M dinitrophenol. You can do that if you want to write the common name. You can also write indicate it with respect to numbers. If you have more than one, you can indicate it with respect to numbers. So here the numbers will be 1, 2, 3, 4, 5. So 3,5 dinitrophenol. 3,5 dinitrophenol will be the common name. If I have to talk about the IUPAC name, 3,5 dinnitrobenzenol. This is how we will name it according to the IUPAC system. So pretty straightforward. In the common system, all you need to do is find out where is that particular substituent, which position it is attached to. Based on the position, you will indicate it either as ortho, meta, or para. Then when you're talking about the IUPAC system, you will not use the terms ortho, meta, para. You will use numbers to indicate the positions, or what we learned last year as locants. All right, I'll just keep the slide for a moment. If anybody wants to just observe this, you're free to do so. And then I'll go to the next one. All right. So coming to the next one. So the next one is a set of compounds here with names. Now these are again substituted phenols. One thing that I want to let you know is if I have a methyl substituted phenol. Now this is a phenol. To phenol I have a methyl group that is substituted. In general, methyl substituted phenols are called as cresols. They're called as what? They're called as cresols. Now when I look at this cresol here, methyl group is at a ortho position to my phenol. Yeah, I can still see people doing some graffiti on my slide. Please refrain. Thank you. So I have a CH3 which is at an ortho position to phenol. So therefore I call it as ortho cresol. And if I have to talk about the uh, name in terms of the numbers or the positions, 2-methyl phenol. So you can use 2-methyl phenol. Now one thing is you can use phenol in both IUPAC terms as well as common terms. So we looked at the exact IUPAC name of phenol, which was benzenol, but you can use phenol in terms of both common system as well as the IUPAC system. So no need to worry why you have a phenol here. So this is 2-methyl phenol. Then coming to this compound here, so this is 3-methyl phenol, or methyl group is attached to the meta position. So therefore it is a metacresol. So I'll have an orthocresol, metacresol, and a paracresol. So these are all called as cresols. We have already looked at orthonitrophenol, and this, and by the way, these compounds are important. One of them will surely be asked in your exam. Write the structure of catechol, write the structure of resorcinol. Yeah, so it's important that you need to know the structures. Catechol is nothing but 1,2 benzene diol. So it's a diol where the OH groups are attached at the first and the second position. That is what is called as catechol. So 1,2 benzene diol. What is resorcinol? Resorcinol is 1,3 benzene diol. It's also a diol. It's just that where are the OH groups that matters. So this is 1,3 benzene diol. Then I have hydroquinone, 1,4 benzene diol. 1,4 benzene diol is hydroquinone. This one is pretty straightforward. I have bromine at the 2 and the 6th position. So at the 2nd and the 6th position, we have bromine. So 2,6 dibromophenol. 2,6 dibromophenol. This is one more substituted phenol where I have a benzene ring attached. Yeah. So this is called as 1-naphthol or alpha naphthol. So I'll just keep this slide for a moment for you to understand how we go about naming phenols. So once again, we follow the same logic. If it is the common system, we use ortho, meta, or para to indicate the positions of the substituents. If it is the IUPAC system, we use numbers. Depending upon where that particular substituent is attached, we use numbers to indicate the positions. All right, then we'll move to the next slide. So till now we looked at how to name alcohols and phenols. We look at how to name ethers. Now I think we are very familiar with the way we write an ether. R O R dash. Yeah, R O R dash is what is the general formula of an ether. So how do we name an ether in both the IUPAC system as well as the common system? Now the common system is easy. Now when you look at the common system, it's easy. All you need to do is find out who are the alkyl groups that are attached across the oxygen. Depending upon that, you will be naming them as alkyl, alkyl ether. So alkyl, alkyl ether is how you name it. Which alkyl should come first, sir? it is dependent on the alphabetical order. So the alphabetical order will decide which R group will be written first, which means if I have CH3OCH3, now the two R groups are methyl groups. Now I do not have any order to be followed because both of them are one and the same. This is a symmetrical ether. So I can call it as methyl methyl ether or dimethyl ether. So let me repeat. If I had CH3OCH3, I will be calling it as methyl methyl ether or dimethyl ether. On the other hand, if I had CH3OC2H5, now here the two R groups are different. So what is the compound here? CH3OC2H5. The two R groups are entirely different. Now when I have different R groups, when I have an unsymmetrical ether, then we need to look at the alphabetical order for writing the R groups. Now which are the two R groups that we spoke about here? CH3 and C2H5. CH3 is methyl, C2H5 is ethyl. If all of you would have done your LKG, UKG first standard well, you know the alphabetical order straight away. Ethyl comes first, followed by methyl. So ethyl, methyl, ether will be the common name. Now let's look at the IUPAC system here. Now what is he saying? IUPAC system, in the IUPAC system, the ethers are named as Alkoxy Alkane. So what is the common way in which we write it? Alkoxy Alkane. Now when you look at this name here, there are two root words. There's one root word here, ALK. There's one more root word here, ALK. Now you can understand why I have two root words. We have two root words because there are two R groups. Now which R group will come here and which R group will come here entirely based on the number of carbon atoms that is present in that particular R group. How do I confirm which is the alkane, which is the alkoxy? This is what is given in the bracket here. The R group containing more number of carbons becomes the alkane part and the other R group becomes the alkoxy part. So it is pretty simple. I have alkoxy alkane. Now, which forms the alkoxy part and which forms the alkane part is the question. The answer to that is very simple. R group.
Higher group forms okay. Alkane part and the carbon and the carbon atoms and
I
after
can
group
see.
and for
Is it
phenol.
Abhiram? Abhiram, you need to mute your device. Yeah, thank you so much. Yeah. So coming to this case, the R group containing more number of carbons becomes the alkane part and the R group and the other R group becomes the alkoxy part. Clear? So alkoxy alkane. Now let's take the two examples that we visualized. The first one that we visualized was CH3OCH3. Now if I have to name it according to the IUPAC system, anyone can become the alkoxy part or the alkane part. Why? Because it's a symmetrical ether where both the R groups have the same number of carbon atoms. So how will I be naming it as? I will be calling it as methoxymethane. So CH3OCH3 will be called as what? Will be called as methoxymethane. Just following this general name here. Then coming to the second name that we were visualizing. The second compound that we were visualizing was CH3OC2H5. Now in this case, there are two R groups and both of them are different. Now you need to find out which R group contains more number of carbon atoms. See, basically when we're talking about IUPAC, we are just following the three steps that we studied last year. In IUPAC, there are three parts to a name: root word, suffix, prefix. Root word is at the center, suffix comes after the root word, prefix comes before the root word. Now root word basically tells me who is my parent chain, or the chain that contains maximum number of carbon atoms. Yeah, we apply the same logic here. The name is obtained by applying the same logic. So going back to the compound that we were visualizing, CH3OC2H5. In CH3OC2H5, C2H5 has more carbon atoms, so that will become my parent chain. And in that parent chain, how many carbons are there? There are 2 carbons, so therefore the root word is eth. And the nature of bonds, if it is single, ethane. So ethane will become this portion. Now to ethane who is attached, I have CH3O. CH3O is attached to my ethane. CH3 is nothing but methyl. So when I put that here in this name, methoxy. So therefore, CH3OC2H5 will be named as methoxy ethane. Clear? Let's visualize one more compound before I go to the exercise. The compound that I want you to visualize is C2H5OC2H5. Symmetrical? Simple? Yeah. C2H5OC2H5. Now, naming this according to the common system is very simple, because we just said all you need to do is write alkyl, alkyl, ether. Now, which is the alkyl group here? Ethyl. So, ethyl, ethyl, ether, or diethyl ether. So, that is your common name. Then coming to the IUPAC name. Now, which are the 2R groups? C2H5 and C2H5. Now, when you look at the rules for the parent chain, both of them can be considered, or any of them can be considered. So if I consider any one of them, the parent chain contains 2 carbon atoms, which means eth. So ethane is what I will be having. And to ethane, what do I write before? I will be writing ethoxy. So ethoxy ethane will be the IUPAC name. Yeah, so I hope we have visualized that. So if you have visualized that, I have a few compounds here for you, which are ethers. I want you to make a note of all these first. So write down the structures of all these compounds.